This is our second type of rational. This is where the bottom degree is bigger than the top. So we know we're going to get a y equals 0 for our horizontal asymptote. All right, so it starts the same way. You want to factor these and see if anything cancels. Nothing cancels, which means we don't have any holes. But our domain here would be from negative infinity. And then so we have x cannot be negative 2 and 1. From negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. So that means x can't be negative 2 and x cannot be 1. So what does that apply here? There are no holes, so these are our vertical asymptotes. So we're going to do the same thing we did before. Find the x-intercepts. We want to know when does this equal 0. So it's just the numerator, which means we have x minus 2. So x minus 2 equals 0. X equals 2. So we can go straight down now. And at x equals 2, put a dot. So now we need the y-intercept. And again, the y-intercept, we just plug in 0. So y equals 2 times 0 minus 4. 0 squared plus 0 minus 2. And so that would be negative 4 over negative 2. And the nice thing, we're going to use a calculator. So if anything's are wrong, we will come back and fix them. Right there. So we now have 2 points. So now vertical asymptotes. And vertical asymptotes are our denominator. So we already know that x cannot be negative 2 and 1, which means we have vertical asymptotes at x equals negative 2 and at x equals 1. So we're going to draw a vertical line at negative 2 and at 1. So now we're getting a better picture of how our graph will look right there. And then now the horizontal. So our horizontal asymptote, remember, is always about top and bottom. So we have small over large. This implies that we have y equals 0. Our function will go off to 0. So again, you just put a little dotted line here and a little dotted line here. And that's all the information we need to graph this. All we have to do now is plug it in our calculator, which I've already done. So I've plugged both of them in so that we have one in blue and one in red. And this is just to verify that the factoring was done correctly. If the factoring is incorrect, it'll show right now. So if I hit zoom 6, you'll see it'll graph the blue one. And then here comes the red one. And everything looks great. And if we look at our table, right, let's go to our table set to get this back to where we need to start it at, which is 0. You can see that we have an error at 1. That was our vertical asymptote there. And then the other one was at negative 2, see? And then there are some values to graph, but I just need rough sketches. So we're going to, within the asymptotes, we are just going to trace. Okay. So like this. And then you come up here and you go, oh, wait, there's a point. How am I supposed to hit that point and come back down? So that leads us to the next question. A very, very good one. Can they cross? Yes, they can. Your graph can cross the horizontal asymptotes, never the vertical. So the way you do that is you look at that point right there. And you already saw that it's at negative 2, right? So what it means is it's going to cross at this point and then come back down this way. So we're actually going to get like a little maximum right there. And then it will come back down to the vertical. So it's not approaching from the top. It's approaching from the bottom. It's approaching from the top. So you can see our graph goes up and then is coming back down. So you could calculate where that max occurs by going second calc maximum. And then a point to the left would be 2. And a point to the right we could just say is 10. That'll zero it in. Too far. So second calc maximum. Point to the left would be 2. 8. And it's right there. So 4 and then 0.222. So you see it doesn't even go that high. It just comes up here and then comes back down. So we're getting that. My graph's a little high, so Let's just move it a little bit lower. And it happens at the 4 mark right there and then comes back down. So they will cross. Can they cross? Yes. It's when this is equal to, where is it? Right here. Was when your point is equal to 0. Whatever the asymptote is, if you have some value that will give you that asymptote, then that's exactly where it will cross. So this is y equals 0. We did have an x value that would equal 0. And there you go. That's how you graph these type.